Hi everyone, I am here to demonstrate the project on longest palindromic substring. The code provided is a Python implementation of three different algorithms to find the longest palindromic substring of a given string. There are three algorithms that are brute force algorithm, dynamic algorithm, managerial algorithm. And the main function first promotes the user to enter the length of the string and generate the random string of the specified length uh, using these function generate random string function and then calls the main function calls all three algorithms. First it calls for the brute force approach and dynamic approach algorithm and manager algorithm. And then all these algorithms are used for the providing the palindromic substring from the given length of the string. And after that, there are three separate loops that calculates the runtime of each algorithm for string of increasing length 1000 to 2000, 2000 to 3000, 3000 to 10,000 using the time it magic function. And these runtime is like brute force runtime, calculating the brute force runtime, calculating the dynamic program runtime, and calculating the master runtime. And then the results are then stored in the three separate list. Here is the list, and that stores empirically observed times and the predicted times. These are the empirical observed times and predicted run times. And then this is like n versus predictor runtime. The code is meant to plot the three different graphs using the MATLAB library in Python. Each graph represents the relationship between the input size n and the predictor runtime for the three different algorithms. One is brute force and dynamic programming and manager algorithm. And then here is the n versus empirical runtime. Here is the code. It meant to plot three different graphs using the MATLAB library in Python, which represents the relationship between input size n and the empirical runtime for three different algorithms. First one is brute force, and the second one dynamic and Menester algorithm. And coming to empirical runtime and predictor runtime comparisons. These code meant to plot six different graphs using the matplot library in Python. Each graph represents a relationship between predictor runtime and the empirical runtime for the three different algorithms. Like one is, as we know, brute force, dynamic programming, and miniature algorithm. The code uses PLT plot function, PLT plot function to plot two line graphs for each graph, for each algorithm. One with red line represent the empirical runtime and other with green line represent the predictor runtime. The n variable in the code used to represent the input size of each graph and the label parameter is used to set the labels for the legend. And all the functions here are used to set the title, legends, and x-axis labels grid respectively. Finally, the PLT show function in the code is used to display each graph. Overall, the code is used to compare the predictor runtime and the predictor runtime to the empirical runtime for each algorithm. The predictor runtime is obtained using some other theoretical analysis of the algorithm, while the empirical runtime is obtained by usually running the algorithms on different input sizes and measuring the time taken for each run.